I think some of the favourite studies that I've done, and the studies that I've been involved with, but also similar ones done by other groups that I haven't, and these are studies that I mentioned before looking at inflection and morphology, so these morphemes that go on the ends of words to change things. And one particularly well studied debate within this is the English past tense debate. So I guess a lot of people watching this video maybe won't have English as a first language, and they will have been taught in school that a regular past tense in English, you simply take the verb and put ed on the verb. So, you know, walk, walked, or talk, talked. So this sounds very simple. So the earliest theories of how English native speaking children learn the past tense were essentially just that. So they learn a rule that you can put an ed on the verb, and that's how it works. But what's interesting is when you look at it in a very fine-grained way, that rule seems to be an oversimplification. So English children, they don't always put the ed on the verb. Sometimes they miss it off, or sometimes they put it on verbs where it shouldn't be there. And what's really interesting is if you look at it in a fine-grained way, the likelihood of correctly supplying the past tense marker or not depends on the particular verb in a way that's to do with the sound of the verb. So it all looks very simple when it's written down. We write ed. But actually, how that's pronounced, and remember, children are learning this a long time before they learn to read or write, so the fact that it's all written ed is no use to them. So a lot of verbs in English, the regular past tense form actually ends in a t sound. So if you think of like missed, wished, hissed, as far as a child is concerned, it's not ed, it's t. So what the data suggest is that they're making a phonological generalization, not based on ed, but based on the sound of a word. So they're learning that a verb that ends in a fricative, so like miss, hiss, wish, dish, or whatever it might be, that these take t in the past tense form. So what's interesting is if you do studies where children are given novel verbs, like to, I don't know, to friss or to gliss or something, the likelihood of them putting a past tense marker on that, so you say, you know, here's a man who likes to gliss, he does this every day, so yesterday he, and the child will say glissed, maybe. So the likelihood of children doing that depends on how phonologically similar the novel word is to the words that children have already got stored in memory. So it doesn't look like these results suggest, it doesn't look like they've got a regular rule that they can just apply to any verb. It sounds like they're producing past tense forms by simply storing all the forms that they know, and when they want to produce a new form, they're just making a phonological analogy, a sound-based analogy across the forms that they've got already stored. So there's no debate that children have a tendency to go beyond what they've heard and to say new things. And the past tense is a great example of that because my own daughter is right in the middle of this overgeneralization period at the moment. Pretty much every time she will say, we sitted down, we goed there, we eated that. She hasn't really learned any irregular forms yet. So children definitely have a tendency to go beyond what they've heard. The question is, how do we best explain that? So there's kind of three different approaches, actually, I'd say. So the first is the genitivist style approach, where it's the formal rule, you take the verb, you add ed on. The second is the kind of mainstream constructivist approach, where it's you store all the different forms and then you abstract across them to make some kind of generalization, but there's still some kind of abstraction. And then you have what I'm actually arguing for in my current writing is a more radical constructivist approach, which is called an exemplar approach, where you don't actually store any generalizations. All you store is the individual forms. So when you generate these novel forms, you're generating them on the fly as you go. You don't have any stored rules or generalizations or anything. All you have is the stored forms. And there are generalizations, yes, but they happen on the fly as you're producing language, as you're retrieving these forms, rather than there being stored generalizations. Until recently, it was thought that there was a critical period for language acquisition, which finished around maybe 5 or 6, that if you're not exposed to a language before that period, then you'll never be able to learn it to a native-like level. But what's interesting is that, but these were generally done on very small scale studies, you know, like 50 or 100 people. What's really interesting is a guy called Josh Hartshorne, who's based at Boston College in the US. He's recently run a huge crowdsourced study across the internet. And I think this is something we're going to see much more and more of, obviously not just in child language, but in science in general, or not just science even, but in everything we're kind of seeing the rise of big data, of web-generated data sets. So what Josh did was very clever. He got people to do an online quiz where it was a neural network, and it would take people's answers. It was like an English grammar quiz, and it would try and predict what was their native language and how long they'd been learning English and so on. But this was just the hook to get people in. Of course, what it was really doing, it was asking them what was their native language, how long had they been learning English, and he was feeding all of this into a big statistical model, which was testing this critical period idea, not just with 100 people or 1,000 people, but with, I think it was several million people that he managed to get to complete this study. And what he actually found was very interesting. He found that there does seem to be a critical period, but it doesn't finish at 5 or 6. It seems to finish around, I think it was something like 16 to 18. So, or was it even later? I'll have to look up the study, but anyway, it was in early adulthood, certainly, rather than childhood. So it obviously makes a difference how you learn. You're not going to become a native speaker just by kind of sitting in a classroom for an hour a week and doing a bit of homework. You need to have something like the experience that children get. But it's very encouraging for everyone who wants to learn English or another second language around the world to know that these critical periods do seem to extend much later than we had previously thought. So in terms of the relationship between language and other areas of child development, what's difficult is that the kind of generativist versus constructivist debate that I mentioned in child language doesn't really have parallels in other areas. Obviously I'm a complete outsider to this field, but say maths, for example. Everyone pretty much agrees that kids just have to learn maths from being taught maths and kind of what they can figure out. There isn't really the idea that children are born with a kind of universal innate knowledge of mathematics that they have to map onto what they know. So it's difficult to draw parallels between language development and other areas. There are certainly overlap with things like concept development and so on. So the example I mentioned earlier about whether we store for language the individual exemplars or whether we form abstractions, that's a debate that's kind of already happened in cognitive psychology, not in a linguistic sense, but if we just set aside the word for it. So think about a cat, set aside the word cat, but just think of a concept cat. So there's kind of 3 different ways of talking about this. The old view was that we kind of had rules about, it must have 4 legs, it must have a tail and so on. But then this doesn't work because, you could have a plastic model cat or a picture of a cat to which none of these things apply. So then the next idea was that we had a kind of a prototype, idealized cat. So we store all our cats in our head and make an analogy across them and have some kind of perfect idealized cat, and we judge other cats with reference to this prototype. But then the third idea is this exemplar idea, that actually all we do is store every encounter we have with a cat or a picture of a cat, we just store all of those in our head. There isn't any separate abstraction process, and we just retrieve the necessary examples of a cat for whatever our task is at that purpose. And actually, no debate in science is ever settled conclusively, especially not in psychology when we can't look in people's heads. But I would say the exemplar view of category formation is probably the dominant one now within category formation. And I think language just needs to kind of catch up with the rest of cognitive psychology here. Yeah, computational models of child language acquisition are very important in our field. So in the old days, you had your theory and it was just kind of like people talk about 1970s box and arrows theory. So, you have a box and then the word comes in and then 3 arrows go out, long-term memory, short-term memory, the grammar, and, no one knows what this really means. But if you have a computational model, then you're forced to make your assumptions absolutely explicit. So some work that I've been involved with, I haven't done the computer side, but so the guy who did it's called Felix Engelman. He works with us at Manchester and Liverpool universities. And it was this, I mentioned before about how learning which marker goes on the end of a verb, so like played, plays in English and so on. But it's actually much more complicated than that in most languages, certainly in Russian, for example. And so we did some studies of Polish and also Finnish, and Polish is quite similar to Russian in a lot of these respects. And so the problem that kids have here is much more complicated than English-speaking kids, but we still think they solve it in the same way by storing all the examples and making a phonological analogy across them to generate these new forms. And what Felix did was built a computational model that does something like this. So it's given the stem of the word in Polish or Finnish, and it has to produce the fully inflected form of the verb. And it does it basically by doing what we're saying here, by analogizing across the stored forms that it has. So computational models are hugely valuable here, because if I just say we do it by analogizing across the stored forms, then people's natural reaction is, what the hell does that mean? Whereas if we say, okay, it works something like this computational model, which stores the forms and can use them to produce the output form, then what we're saying at least hopefully starts to look vaguely plausible. Okay, a question that comes up a lot in, particularly for second language learning, is whether some languages are easier or more difficult than others. And I guess there's two ways to answer it. The first is to say it kind of depends where you're starting from. So if you're learning, if your first language is English, then learning Hebrew is going to be horrendously difficult. But if your first language is Arabic, then learning Hebrew is going to be, easier than learning English. So learning a language from within your own language family, or one that's historically related to your own language, is obviously going to be a lot easier. I guess what people really want to know when they ask this question is, if we could somehow have an alien, would it be simpler for them to learn one language than another? Well, again, I guess it would sort of depend where that alien was coming from. But I think what happens is language tends to sacrifice complexity in kind of one part of the grammar and bring it in somewhere else. So English, certainly, I think it's probably easier to get to a kind of basic level of English than it is many other languages, just because, as I mentioned, when comparing English to Polish or Russian, we don't have all these different forms of a word. We have plays, played, playing, and that's it. We don't have igrаю, igraish, igraiche, all these different forms that we have in other languages. So I think to get to a level where you can just say the words that you want to say, where you can just retrieve the vocab and spit them out in some order that will make some kind of sense, probably English is a little bit easier than what we call these highly inflected languages. But certainly to convince someone that you're a native speaker, I wouldn't want to say that any language is easier or more difficult than others, because the nuances that English can't do with morphology, it has to do with other ways, like the vocab or the more rigid word order and so on. So these things tend to balance themselves out.